Hello everyone, welcome back to the channel Chem Science. I hope everybody is doing fine, isn't it? Today we will be studying the super tricks of the electrochemistry. Right, so I want everybody to pay a lot of attention because now this time I I am pretty much sure that you have not studied these kind of tips and tricks anywhere in any book or by maximum to maximum of the faculties. This is my guarantee. Today we will be studying so much awesome tricks that whatever the exam you are writing, you can solve the question within 1 minute. I'm not saying 2 minutes, I'm saying 1 minute. Many student during the what you can say is during the practice session of the numerical, they feel like the question is lengthy, we cannot balance the reaction. What if we really cannot balance the reaction? What if we really cannot find the n factor while calculating the number of electrons or calculating the charge or calculating the weight which is liberated or which is being dissolved? What if we don't know the balancing of the reaction or finding the n factor? So today we will be learning an awesome trick, literally awesome trick, which is applicable to any and every question. Mark my word, any and every question for sure. So let us directly go to the topic. So we are studying today the first law of Faraday, and then we would be studying, because today the numerical chapter, isn't it? So 2-3 lectures, like 10 to 20 minutes, there will be lecture of 10 to 20 minutes. We will be sharing these tricks in part 1, 2, 3. Right, so my target is not to go beyond like 20 minutes of the video, so that within 20 minutes you learn something in part 1, 2 and 3, 4 and so on respectively. So right, so let us go back to the topic. So we have first law of thermodynamics, sorry to say the first law of Faraday. We are studying it. So what is first law of Faraday? First of all, we'll go through the definitions, then we will go through the practical definitions, then we'll go into the numerical, and then we'll learn the trick that how the numerical usually look like. It is very difficult, but how we can put the numerical to solve in like within 1 minute, right? So this is the first law of thermodynamics. Everybody knows it, that the amount of substance deposited or discharged at an electrode is directly proportional to the amount of charge passing through the solution. Solution may be molten solution like sodium or aqueous, right? Again, that is amount of substance deposited. Read it here, amount of substance deposited or discharged means dissolved, isn't it, at any electrode like cathode or anode is directly proportional to the amount of charge passing through the solution. That is, more the charge, more the amount deposited or you can say liberated or discharged, it means faster is the reaction, isn't it? So what we will say, more the charge, faster will be the reaction, more will be the deposition, isn't it? So like if you double the charge, the weight liberated will be doubled, obviously, you know very well. So what we can say, the weight in grams is directly proportional to Q. Weight in grams is directly proportional to Q. That is, now what we will do with this sign of like we can say proportionality sign with the Q, what we will do with this sign, we will put a constant W equal to ZQ, and Z is the electrochemical equivalent. Z is electrochemical equivalent. It is the constant of proportionality, which is called electrochemical equivalence. Now, in class 11 in South India, they say junior class. In North India, they say class 11. So, like we say the in class 11, we have studied the law of equivalence, isn't it? And what is that? It is one equivalent of electron. Law of equivalence says one equivalent of electrons are passed through the solution, means those one equivalent of electron will produce one equivalent of substance. Again, one equivalent of charge, or you can say the electrons, one equivalent of electrons will produce one equivalent of substance. Where it is producing in electrochemistry, in electrolysis, they are producing on the electrode. So cutting short, one equivalent of electron will liberate or discharge one equivalent of substance. Final. One equivalent of electron will liberate one equivalent of the substance at the electrode, at the corresponding electrode. So we will say, so when we say equivalent of the substance, so substance has a weight, that's why we say one equivalent is equal to equivalent mass. It is represented by equivalent mass or simply E, right? So let us say, how do we understand it equivalent mass? For example, we understand molar mass. Molar mass means mass of 1 mole. In the same way, molar mass means mass of 1 mole, that is m grams. In the same way, equivalent mass means mass of one equivalent. Mass of one equivalent. So what do we say over here? We say mass of one equivalent. So if one equivalent of electrons are passed, means what do we say? 1 mole of electrons are passed. One equivalent of electrons are called 1 mole. One equivalent of electrons are called 1 mole of electrons, because n factor is equal to 1. Okay, n factor is equal to 1. Now you will say, what is this n factor? Number of moles multiplied by n factor equal to number of number of equivalents. So if n factor is equal to 1, it means number of moles equal to number of equivalents. So we will go into this n factor thing in very much detail. If you have studied in class 11 about n factor, that is well and good, or else we will go into very much detail that how one equivalent of electrons are equal to 1 mole of electrons. So 1 mole of electrons, in previous lecture we have studied, it is equal to 1 mole of electrons is equal to one equivalent of the charge, or is equal to 1 Faraday, or is equal to 96500 coulomb. This we have studied. 1 mole means the charge on one electron multiplied by Avogadro number. That is what we are doing. 1 mole of electrons means how do we write? 6.023 into 10 to the power 23. This is Avogadro number, multiplied by 1.6 into 10 to the power minus 19 coulomb. So this value comes out to be near equal to 965,000 coulomb. This is equal to 965,000 coulomb. That is 1 mole or one equivalent of electrons means 965,000 coulomb, or equal to 1 Faraday. So when we say W equal to ZQ, obviously we have studied it. This is the first law of Faraday. When we say this one, W equal to ZQ, and if we put Q equal to 1 Faraday, 1 Faraday means 1 mole of electrons or one equivalent of electrons. So one equivalent of electron produce one equivalent of mass. So W is replaced by this E. W is replaced by this E. So clearly what we are saying is, if we put Q equal to 1 Faraday or 1 mole or one equivalent of electrons, one equivalent of electrons will produce one equivalent weight or one equivalence of the matter or the substance, that is represented by E. E is the equivalent mass. So this implies Z equal to E upon 96500. Now this becomes formula Z equal to E, and using this Z over here into this formula, if we put this Z into this formula, what do we get? This from this formula, what do we get? We get this formula. Put it in the box. Everybody understands that? We are using it into the box. Now the formula became, now remember this formula, okay? Learn it. W equal to EQ upon 96500. That is the weight of the substance liberated. That is weight of the substance liberated, W. Where it is liberated or discharged? On the electrode. That is amount of substance liberated on the tell me, on the electrode, is equal to equivalent weight of the substance multiplied by total charge supplied divided by 1 Faraday, 96500. So clearly we understand and learn this formula. Now this became a formula, and because Q equal to I into T, current into time, so we write W equal to ZQ or W equal to ZQ or W equal to EQ upon 1 Faraday or W equal to EIT upon 1 Faraday, which is equal to 965,000 Coulomb. Right. So in class 11 we have studied one thing. Let us put some learning of the revision. We studied that weight upon equivalent weight equal to number of equivalents, and we have studied weight upon molar weight equal to number of moles. We have studied this to weight upon molar weight equal to number of moles, and weight upon equivalent weight equal to number of equivalents. True. So now we have studied that number of moles, we have studied that the number of moles multiplied by n factor equal to number of equivalents. Number of equivalents. And if this is the case, number of moles multiplied by n factor equal to number of equivalent, if this is the case, using this case over here, interconnecting them, what do we get? Divided them, we get, let us divide W by E upon W by M equal to number of equivalents upon moles. Cancelling this, M by E, we get, now this is equal to, now put equivalent equal to number of moles into n factor. So when we use over here moles into n factor upon moles equal to molar weight upon equivalent weight, that becomes equal to moles, we cancel from numerator and denominator. So molar weight equal to equivalent weight into n factor. Now remember it. Molar weight equal to equivalent weight into n factor. Okay, everybody understands that. So I am erasing for the better visibility now. Okay, you can rewind the video, you can see to it. I am erasing just for the better clarity of the video. You can rewind it and you can find it. So we have just studied this formula. Okay, so I am just erasing it for the better clarity of the video. Okay, correct. So let us proceed further. So we have studied that, now we have studied number of this, we have clearly studied, look, n factor multiplied by equivalent weight, equivalent weight equal to molar weight. This is, M is the molar, okay, molar weight. So if this is molar weight, we get equal to M by NF Everybody understands that? Now again, using this E into this formula, we get M by NF. We get a new formula, M by NF, isn't it? And then sending this M over here in the denominator, what we are getting this formula, W by M equal to N. N is the number of moles. So number of moles liberated. Now we have cut shorted the formula, equal to IT, that is Q upon N factor into Faraday. Now let us revise the formula. The first formula was W equal to ZQ, it is over here. And the second formula is, it is over here, W equal to EIT, and then W equal to molar weight upon N factor, we know it already, and then we are just rearranging the formula like this only. So we don't need to worry about it. What we need to worry is, we need to learn the formula, which is the final one. So this is the final one. Number of moles equal to Q upon N factor into 1 Faraday. 1 Faraday is equal to 96500 coulomb. So let us understand. So now we have derived the formula from a single formula. We have derived the different part of the formula, and all these formulae are the derived form of the first law of Faraday. So first law of Faraday is number of moles of the substance liberated or discharged. This is the first law of Faraday. Number of moles of the substance liberated or discharged is equal to total charge supplied upon N factor multiplied by 96500 coulomb or multiplied by 1 Faraday. Okay, now calculate N factor. Now N factor calculation, we are studying this. This is the N factor calculation. And how do we calculate N factor? N factor is nothing but it is the charge on cation or charge on anion or the number of electrons gained or lost. We are not going into the detailed definition which we have studied in our class 11. We are studying for the sake of solving the problems of electrochemistry. So number of moles equal to N factor, number of equivalent equal to number of moles into N factor, and N factor is equal to the charge appearing on the cation or anion. So here, or the number of moles of electron gained or lost. So in this equation where Na positive is getting 1 electron becoming sodium, N factor equal to 1. So obviously here it is getting 2 electrons, so obviously N factor is equal to 2. It is getting 3 electrons. So N factor is the number of moles of electrons gained or lost per mole of the salt or per mole of the species. Number of moles of electrons gained or lost per mole of the species. So here what is N factor? Here what is the N factor? We will check the oxidation number. Here the oxidation number is 0. Obviously it is a free species. Here the oxidation number is -1, isn't it? So what do we say? From 0 to -1, and what is the change in oxidation number tells us? It tells us the number of moles of electron gained or lost. So obviously change in oxidation number will tell us about the N factor. The change in oxidation number will itself be N factor. So it is going from 0 to -1. So one atom is going from 0 to -1, gaining 1 electron. So in total it is I2. So in total there are 2 atoms. So 2 atoms will gain 2 electrons. So N factor equal to 2. The total atoms are 2. Every atom is gaining 1 electron. So number of electrons gained or lost, here total number of electrons gained equal to 2. So N factor is equal to 2, right? Now we will understand a trick. How do we find the N factor? We will understand a trick. Okay, and the trick is very beautiful, literally. It is an awesome trick. Let us see. Let us move to the trick and let us see how do we get it. So here we do have a trick. Like, how do we do it? Finding the N factor. First of all, balance the reaction. Balance the reaction. So how do we find the number of electrons or the N factor? How do we find that? We will find N factor equal to number of electron involved per molecule, gained or lost again. Okay, simply balance the reaction. Let us say how do we balance it and how do we find it. Let us say we have a reaction A plus 2B plus 3C gives 4D plus 12 electrons. Now let us say this is a balance reaction. Okay, we are assuming it is a balance reaction. So n factor with respect to A, it will be 12, because 1 mole of A, it is losing 12 electrons over here. Okay, and what is the n factor with respect to B? That is 1 mole of B, 2 moles of B are losing 12 electrons, so 1 mole will be losing 12 upon 2. Check it. 1 mole is losing 12 electrons, as we can see in the reaction over here. And then what do we say? 2 moles, because B is 2 moles 2B. The stoichiometric coefficient tells us the number of moles in the reaction. So tell me, now solve this yourself. Obviously 12 upon 3. So n factor with respect to C is 12 upon 3 equal to 4. And n factor with respect to D will be how much? 12 upon 4 equal to 3. So number of moles of electrons involved per molecule or per mole. Per molecule or per mole of the species which is considered in the reaction. Everybody understands that? Very well. So n factor equal to number of electrons upon the stoichiometric coefficient appearing. N factor equal to number of moles of electrons upon stoichiometric coefficient. Let us say a very peculiar question we are taking, a very peculiar example, and please remember this example. This is very much important, very much important. We have HSO4 negative over here, and it is converting into H2S2O8. Now how do we find it? Simply balance. Okay, the trick is simply balance. Balancing is very easy. In the electrolysis, balancing is not difficult. Okay, because it is simple balancing. Here there is one hydrogen, there are two hydrogen, put a factor of 2 and simply multiplied by 2 and the reaction is balanced. So if this is balanced, how do we do it? Check it out. 2 moles of H2SO4 is producing H2S2O8. Here there is 2 charge, 2 negative, so to balance the charge we have to put 2 electrons. Very simple.